What's up, everybody? Mr. Kozad back again for another video lesson. This time our content is the Quadratics unit, and we are going to look specifically at Intercept Form. So if you are one of my students, welcome back to another video experience. I hope it's awesome for you. If you are not one of my students and you just randomly found this video because you're working on Quadratics and Intercept Form, welcome. The most important thing you've got to hear today is that today is a great day to be alive. And I'm so excited that you found it. I hope this video is helpful and beneficial for you. Do me a favor and be ready to pause. You can fast forward, you can rewind, you can go through this video at whatever pace works the best for you. It would be a good idea to have some paper out to take some notes and to practice some of these problems along with me. But otherwise, here we go. We're going to jump right in. So here are the notes that I use for class to go over Intercept Form. Okay. So Intercept Form, as you see at the top, I'll highlight it for you, is y equals a times the quantity x minus m times x minus n, where m and n are the x-intercepts, okay? So it's also important to note here that the a value, okay, the a value tells us the same information, and that's whether the parabola opens up, whether the parabola opens down, whether it's a vertical stretch or a vertical compression. The purpose of this video is not to go through the effects of A and how to identify what these are. So if this stuff looks kind of foreign to you, you're not really sure what I'm talking about on that, you definitely would want to find a different video. But like I said, the A value tells us the same information. We'll go through some of these through some of the sample problems that we do together today. Okay, so how do we find the vertex when we're given something in intercept form? Okay, so consider this equation, y equals the quantity x minus 1 times x minus 5. So this is already factored. Okay, it's already factored for us. You probably have already learned in whatever unit you're doing with quadratics, you've already learned how to factor. So this is already factored for us. So what we do when we find x-intercepts is we set that function equal to 0, and then we solve for x in each one of those factors. So we have x minus 1 can equal 0, or x minus 5 could equal 0. So we'd add 1 to both sides to get x equals 1. We'd add 5 to both sides to get x equals 5. So these translate to our x-intercepts. So one of them is going to be at 1, 0. The other would be at 5, 0. So the next thing we're going to do is we're going to go over to this graph and we're going to plot those points. 1, 0, and 1, 2, 3, 4, 5, 0. I plotted my x-intercepts. Now the next observation that I want to make is whether or not this parabola opens up or down. This will be a good piece of information that will help us in just a minute. So again, I told you earlier that the a value tells us whether it opens up or down. So if we look at this function, we see that the a value is actually 1, okay? If you don't see a specific coefficient there, that you would assume that the a value is 1. So most important thing to notice here is that that is positive. So that means that this parabola is going to open up. It's going to open up. That'll be really helpful for us. All right. Now let's talk about the vertex. Now one thing that's nice about the vertex when you're dealing with intercept form is the vertex is kind of the midpoint of the intercepts. So what you want to kind of think about is you want to think, okay, how far apart are those two x-intercepts? So one's at 1, one's at 5. That's a total distance of 4. Okay, so that total distance there is 4 units apart. Well, if I cut that in half, that would be 2 to the right of this x-intercept and 2 to the left of this x-intercept. So it's going to be somewhere along this line right here, okay? So that is actually our axis of symmetry. So I'm going to go ahead and I'm going to draw that in, the axis of symmetry. Now, the reason why it was important just a few seconds ago to talk about this parabola opening up is that'll tell you the vertex has to be somewhere on this axis of symmetry. But what that tells you is whether you go up or whether you go down on the axis of symmetry. And since this parabola has to open up, you know that we're going to have to go down somewhere in here to find my vertex. So to find the vertex, here's what I know right now. I know my x value is 1, 2, 3. I know the x value is 3 because that's the axis of symmetry. So to find the y value, you take your original function and you plug x equals 3 in for every x that you see, and then we simplify. So 3 minus 1 would be 2. 3 minus 5 would be negative 2. 2 times negative 2 is negative 4. So that tells me the y value of my vertex. So I go down to 1, 2, 3, 4. Now, if I'm going to draw a sketch of this graph, I'm going to find one more point. Okay, I'm going to find one more point. I'm going to find the y-intercept. That'll be a helpful point for me. So to find the y-intercept, x is 0. So I'm going to plug a 0 in for every x that I see and solve for y. So that's y equals 0 minus 1 times 0 minus 5. That would be negative 1 times negative 5, which equals positive 5. So my y-intercept is at 0, 5. So let me graph that. Go up 1, 2, 3, 4, 5. And then we can use the property of symmetry of a parabola to reflect that across the axis of symmetry and find another point. This point's going to be 3 to the right of the axis of symmetry. And then that gives us a pretty good idea of what this parabola is going to look like. So I can very carefully sketch that in. So again, the key takeaway here, and that we're going to practice in some problems coming up, is that the vertex is kind of the midway point or the midpoint of the intercepts. Okay, so that'll be kind of a key concept for today. We're going to find the intercepts, we're going to find the midpoint, and then we're going to fix our axis of symmetry along that midpoint, and then we're going to figure out the actual location of our vertex, whether it goes up or whether it goes down. Okay, so look at example 1. Okay, example 1 says find the axis of symmetry, the vertex, the x-intercepts, and y-intercept of y equals x plus 2 times x minus 6. So what we're going to do first is I'm just going to rewrite the function here just because I can have it all in one spot. So that's x minus 6. Okay, the very first thing that I'm going to do is I'm going to find the x-intercepts. And to do that, we set y equal to 0. And then we're going to solve for x. Now again, this video is assuming that you've already solved quadratic equations that by factoring so that you're pretty comfortable with what to do next. So then we take each factor and we set it equal to 0, and then we solve. So we get x equals negative 2, and we get x equals positive 6. Now notice on this one I did not give you a coordinate plane for graphing, and that's okay. But I'm going to actually draw just a rough sketch of a coordinate plane because it helps me personally visualize this when I can see where the x-intercepts are located. So one of them is going to be at negative 2, which could be approximately right there. The other one's going to be at positive 6. Now, the next thing that I'm going to look at is I'm going to find the midpoint, what's halfway between negative 2 and 6. So what I'm going to do is I say, okay, the total distance between those two x-intercepts, if this one's at negative 2 and this one's at 6, that total distance is 8. So if I cut that in half, that's going to be 4 and 4. So that means I'm going to go 4 to the right of negative 2 and 4 to the left of 6 and see where I land. That's going to end up being the line x equals 2. So remember, your axis of symmetry is halfway between your x-intercepts. In this particular case, that's at x equals 2. And now I know that my vertex is going to be somewhere on that line. I just need to know whether it's going to go up and it's going to be a parabola that opens down, or does the vertex go down and that give me a parabola that opens up. That's where we go to the original function and we check out the a value. The a value here is, we don't see one, but if there's nothing that you see there, the a value is 1. And specifically what we're looking for here is we're looking for whether it's positive or negative, okay? That's positive, so this is going to be a parabola that opens up. So that vertex is going to be somewhere down here in quadrant 4, where we go down along the axis of symmetry. So let's actually figure out the coordinate of that vertex. Now, for the vertex, I know that my x coordinate is 2, and I'm going to plug and chug to figure out what the y value is. So take your equation and plug a 2 in for every x that you see. So 2 plus 2 gives me 4. 2 minus 6 gives me negative 4. 4 times negative 4 is negative 16. So that's the y value of my vertex. It's 2, negative 16. So let's see if we found everything so far. We found the x-intercepts, and I probably should have written those as a coordinate, an ordered pair. That was negative 2, 0, and 6, 0. We found our x-intercepts. We found our axis of symmetry. We found our vertex. The only thing we haven't found at this point is the y-intercept. So remember for the y-intercept that you let x equal 0, and you figure out what y equals. So y equals 0 plus 2 times 0 minus 6. That will end up being 2 times negative 6, which equals negative 12. So my y-intercept here is at 0, negative 12. Okay, let's try number 2. Okay, a new equation. Now, you can already tell by looking, same directions, but this one has a coefficient, okay, that's other than 1. In fact, the a value here is negative 2. So if the a value equals negative 2, that means that this parabola is going to open down. That's going to be an important thing to help us find our vertex. We'll keep that in mind. Okay? The first thing I'm going to do is find my x-intercepts. So to find your x-intercepts, you set y equal to 0, and then we solve for x. Now, when you have a coefficient here in front of the binomials that are already factored, you can divide both sides by negative 2. Okay, so if we divide both sides by negative 2, 0 divided by negative 2 is 0. So that leaves me with x minus 3 times x plus 9 left over. So then I take each one of those binomials and I set it equal to 0. And I solve. So I get x equals 3. And I get x equals negative 9. Now, if I translate those to an ordered pair, that would be the point 3, 0, and that would be the point negative 9, 0. 3, 0, and negative 9, 0. Now, again, you might be able to visualize this better than me, but I like to see it, so I'm going to draw just a rough sketch of a coordinate plane, and I'm going to put one x-intercept at 3, 0, and I'm going to put 1 at negative 9, 0. Because what I want to try is I want to try to find the midpoint to find my axis of symmetry. So I abbreviate axis of symmetry AOS, okay? So my axis of symmetry is going to be x equals something. So I need to find the x value that is halfway between negative 9 and 3. So to do that, I'm going to count the total distance between them. Negative 9 to 3 is a total of 12. That's 12 units. And then what I'm going to do is I'm going to divide 12 in 2. So that would give me a distance of 6 and 6. So I basically start at each end and I work backwards 6 steps and see where I end up. So that would end up putting me at x equals negative 3. So that's my axis of symmetry. It's x equals negative 3. Now for the vertex has an x coordinate that will equal negative 3. We just have to find the y coordinate. So again, go back to your equation and we're going to plug and chug. We're going to substitute negative 3 in for every x that you see, and we're going to see what we get. So we have -2. -3 minus 3 is -6. And then -3 plus 9 is +6. So -6 times 6 is -36. -36 times -2 would be +72. Yeah, that's a pretty big number, +72. Good thing I didn't ask you to graph this one because that would be obnoxious and difficult to graph. Okay? So we're not surprised by that because we made the observation earlier that that parabola is going to open down. So that vertex would be somewhere above the x-axis, and we can see very clearly that that's going to end up opening down. So the only thing we haven't found here yet is the y-intercept. So when we do that, we're going to plug a 0 in for x. So we have y equals -2 times 0 minus 3 times 0 plus 9. So I have -2 times -3 times 9. -2 times -3 is 6. 6 times 9 is 54. 54. So my y-intercept is at 0, 54. Again, the key to this problem is finding the midpoint of the two x-intercepts, and that line becomes the axis of symmetry. Okay? Let's look at another one. Okay, find the axis of symmetry, vertex, x-intercepts, and y-intercept of y equals x plus 5 times x plus 2. Okay? So first thing we're going to do is find the x-intercepts. To do that, we set the function equal to 0. 0 times x plus, or 0 equals x plus 5 times x plus 2. Then you set each one of those factors equal to 0, and you solve. X equals -5, x equals -2. So if we translate those to some points, we're at -5, 0, and we're at -2, 0. So again, you don't have to do this, but I like to draw a sketch to see what's happening here. I have one x-intercept at -5, 0, and one of them's at -2, 0. -5, negative, that looks like a 3. Let me change that. -2. So we've got to find the halfway point between -5 and 2. So if I count that total distance is 3. Now this is a little bit different because 3 is not an even number, so it's not evenly divisible by 2. Okay? So if I divide by 3, or I'm sorry, if I divide 3 by 2, that would give me 1.5 and 1.5. So you're basically moving either to the right of -5 and to the left of -2, 1.5 units. So that would put me at -3.5. X equals -3.5. So that's my axis of symmetry. My axis of symmetry is x equals -3.5. And that becomes the x value on my vertex. So my vertex is at -3.5. And I need to find the y value. The way we're going to do that is we are going to plug and chug into that equation. So we have y equals -3.5 plus 5 times -3.5 plus 2, and we're going to see what we get. Now, for my students, I definitely would allow you to use a calculator to help you with this work, okay? So we get -3.5 plus 5, that would give us 1.5, and then -3.5 plus 2 would give me -1.5. So when we take that product, we get -2.5 2.25. Negative 2.25. So that's going to be my y value on my vertex. It's negative 2.25. Now don't panic because it's decimals. Those are easy decimals to work with. 0.25, 0.5. Those are easy decimals that should make us pretty comfortable. So the only thing we haven't found yet is the y-intercept. And to do that, we plug a 0 in for x and see what we get for y. So let me come over here and do that. So we have y equals 0 plus 5 times 0 plus 2, which equals 5 times 2, which obviously equals 10. So there's your y-intercept, 10. So don't panic if you have a decimal. It's nothing to worry about. Okay, next one, example 4. Okay, why don't you take a minute and pause the video here, and why don't you try example 4 on your own and see what you can come up with. All right, welcome back. Hopefully you paused the video and tried this yourself. If you didn't, there's no way you got it all done in that little amount of time. But here we go. I'm going to go through this one maybe a little bit quicker than the ones previously. Okay, so next, first thing I'm going to do is I'm going to find the x-intercepts. So I've got the function that I'm going to set equal to 0. And then I am going to multiply both sides by negative 2 to get rid of my 1/2. So that gives me 0 equals x minus 4 times x plus 1. Then I set each one of those binomials equal to 0. And I solve. X equals 4, x equals negative 1. So those translate to a few points. That's going to be at 4, 0 and negative 1, 0. So again, you know that I like to draw a sketch. I like to draw a sketch and see what's happening here. So 4, 0 would be over here. Whoa, sorry about that. Negative 1, 0 would be approximately right here. And I know I've got to find the midpoint. So I count the total distance between negative 1 and 4 to be 5. If I cut that in half, that gives me 2.5 in each direction. So I'm going to go 2.5 in each direction. So if I go 2.5 in each direction, I end up at x equals 1.5. That is my axis of symmetry. So my axis of symmetry is x equals 1.5. So I use that in my vertex as the x-coordinate, 1.5, and I plug that into the function anywhere where I see an x. So that's y equals negative 1/2 times 1.5 minus 4 times 1.5 plus 1. I'm going to have a calculator help me do all this. I'm going to type it all in, negative 1/2 times 1.5 minus 4 times 1.5 plus 1, and I get 3.125. So the y-coordinate is 3.125. Now, the last thing that I need to do here is find the y-intercept. So to find my y-intercept, I am going to plug a 0 in for x and see what I get. So y equals negative 1/2 times 0 minus 4 times 0 plus 1, which is negative 1/2 times negative 4 times 1, which would equal positive 2. So there's your y-intercept. Okay, switching gears here on the last two problems is we're also going to kind of work backwards sometimes to write a quadratic function in intercept form that has the given x-intercepts at 2, 0, and negative 6, 0, and that passes through the point 0, negative 36. Okay, so here's what we're going to do. Start with the y-intercepts. So we don't know what a is yet, but we know that one x-intercept is at 2. So that would be a binomial of x minus 2 times x plus 6. as we work backwards from those. Again, I should probably show you that. So if you had an x-intercept at x equals 2 and you worked backwards, that would be x minus 2 equals 0. That binomial comes right over here. Then we have x equals negative 6 if we work backwards. That's x plus 6 equals 0. And that binomial comes right over here. So when you're given the x-intercepts, that allows you to find the two binomials, but we still haven't found the a value. That's what this extra point is given to us for. So we know that y equals negative 36 when we plug a 0 in for x. So plug a negative 36 in for y and a 0 in for each x. And then let's simplify. So that's negative 36 equals a times negative 2 times 6. Negative 36 equals a times negative 12. And then divide both sides by negative 12, and we get a equals 3. So then all we have to do next is put it all back together. So our equation is y equals 3 times x minus 2 times x plus 6. And that would be my equation. Number 6 would be a good one for you to pause and work on yourself and see if you can get it before I go through it. So go ahead and pause the video now and see what you can do. All right, welcome back. Hopefully you actually paused and worked on it. If not, here's your last chance to pause and actually do it before I start talking about it. It's my disclaimer. Spoiler alert. All right, here it goes. Write a quadratic function in this form. It's in intercept form that has x-intercepts at x equals 1 and x equals 11. So I'm going to work backwards to get those binomials. That would be x minus 1 equals 0 and x minus 11 equals 0. So then I'm going to build that equation. So y equals a times x minus 1 times x minus 11. Now, if you flipped the order here, if you did x minus 11 times x minus 1, that is totally fine, no problem. Okay, there's no problem at all. So now to find a, that's what they give you the second point for. You plug and chug. So you know that y equals 48 when x equals 3. So I plug a 48 in for y and a 3 in for each x, and then we simplify. 48 equals a times 2 times negative 8. So that gives me 48 equals a times negative 16. So then we divide both sides by negative 16, and I get a equals negative 3. A equals negative 3. So last step is to put it all together. Y equals negative 3 times x minus 1 times x minus 11. Circle it, be proud of that, show that off. You did awesome. Hopefully this video was helpful. If you made it all the way to the end, man, you are the real MVP. I'm so proud of you for making it all the way to the end. I hope you learned something that you didn't know when you started or got better at something throughout this video. Feel free to let me know what you think, and I will catch up with you guys next time. Peace in the streets.